In this lesson and the next few lessons, we're really going to begin looking at the graphs of functions. So the first thing we're going to do is we're going to look at the graph of what we call parent functions, and we have about 6 different parent functions that we're going to look at, and the parent functions are just the basic functions. So the first one is the constant function. So the constant function is f of x equals some constant. So c is going to be our constant. So our constant can change, it can be any number, but whenever you graph a line f of x equals c, you really can think of this as y equals c. Remember we said f of x is our output, so it's like our y values. And if you remember, whenever you graph y equals a number, you always get out a horizontal line. So this is always just going to be a horizontal line through c. So for example, if I wanted to graph the line f of x equals 6, that means I would have a horizontal line going through 6. So this would be the line f of x equals 6. So then the domain of constant functions, if you look at this graph, you're always going to have all x values included. So it's going to be negative infinity to positive infinity. But the range is just going to be whatever that c is. It's just going to be one single element. So the outputs are only 6 for this one. But I'm going to leave it as c because it's going to depend on whatever the constant is. And then the next type of function is called a linear function, which is basically in the form y equals mx plus b, where the slope is 1 and the y-intercept is 0. So even though this previous function is a line, we call it a constant function because it's when f of x equals a constant, where the next one is when f of x equals x. So f of x equals x. So basically this means the slope is 1 over 1, or up 1 over 1, and the y-intercept is 0 because there's no number at the end. But if you think of this in terms of like an xy table, and let's say we just want to get some points on either side, -2, -1, 0, 1, and 2 I'm picking, just so that I get some negatives and some positives. If you take these and you plug them into this function, if you plug in -2 for x, you're going to get out -2. -1, you get out -1. So you basically plug these x values in, and you get out whatever you plugged in. So the graph of this is going to be -2, -2, -1, -1, 0, 0. The inputs and the outputs are all equal. So this is that line y equals x, where it's the diagonal line that goes through the center from corner to corner if you have a square grid. So we can go ahead and get our arrows on there. So this is f of x equals x. And then let's just look at the domain and range of this graph. So the domain of this, so looking across the x values, I could have plugged in any x values I wanted and I would have gotten out an output. There wouldn't have been any errors or any undefined values. So that means the domain is all real numbers. And that's what we've been saying. Whenever we have a line, the domain is all real numbers. And the range, well, if you look from bottom to top, you're going to include all y values because these have arrows, so they're just going to keep getting smaller and keep getting bigger. So the range is also going to be negative infinity to positive infinity. So then the next parent function that we're going to look at is the quadratic function, which we've already looked at. So the quadratic function, when we talk about it as a parent function, is just f of x equals x squared. And if you remember, quadratic functions are the shapes of parabolas, so they have symmetry. So that means when I go to write my table, I want my table to include values so that I have the vertex in the middle. And since this doesn't have any numbers in front or any numbers at the end, I know that this is going to be centered at the origin, or it's going to be symmetric around the origin. So I'm just going to include a couple points on either side. So if I square -2, or if I plug -2 in, I'm squaring it, I'm going to get 4. If I plug in -1, I'm going to get 1. If I plug in 0, I get 0. If I plug in 1, I get 1. And if I plug in 2, I get 4. So we plot those points. and we connect those, trying to make those as U-shaped as possible. And we can go ahead and we can put our equation on there. So f of x equals x squared. Label our axes. And there's our quadratic function. So that's the parent function for quadratics. It's the basic. There's no shifts. There's no movements on it. It's just x squared. So the next thing is to look at the domain and range. So domain, what x values could you plug in? Well, I could plug in any x values I want, and I'm going to get out some y value. So the domain is going to be negative infinity to positive infinity. And remember, we talked about this. There's no restrictions on this. So the domain is going to be negative infinity to positive infinity. The only restrictions are going to be when you have the square root and if you have fractions, because you can't have 0 in the denominator. And then the range is going to be where it's different. So you go from bottom to top, you don't have any negative values that will ever be included in this function because the arrows are both pointing up and the minimum value is at 0, 0. So that means I have to start at 0 for the range, and it's going to keep on going to negative infinity. I'll be able to include all y values up to positive infinity. I think I just said negative. Positive infinity. So 0 to positive infinity. So then the next one we're going to look at is the opposite of squaring something, which is the square root function. So the square root function undoes something that's been squared, which is a quadratic. So let's look at this. So the square root function is f of x equals the square root of x. And for this one, we're going to start off with our table. And hopefully you're remembering whenever you take the square root, there's a restriction. There's a restriction for the domain of this, which means that's going to limit me to what x values I can plug in. We cannot take the square root of a negative number. Remember, if you take the square root of a negative number, you get an imaginary number. So if we're talking about graphing this on the real coordinate plane, we can't have any imaginary numbers. So that means I can start with a minimum of 0, because I can take the square root of 0, but I can't take the square root of anything smaller than 0. So I'm going to start with 0 for my x value that I plug in. And then I'm going to use 1. So let's start by plugging these in. So square root of 0 is 0. Square root of 1 is 1. If I do 2, square root of 2 is going to be a decimal. So I'm just going to skip that one instead of worrying about graphing decimals. And I'm going to move on to 4. And the reason why I move on to 4 is because if I take the square root of 4, I get a nice number. Where if I did square root of 3, I would have gotten a messy decimal as well. So then the next number that would be convenient to plot would be 9. Because if I take the square root of 9, I get 3. So basically, if I take the square root of perfect squares, I'm going to get these whole numbers as outputs, which is convenient for graphing. So I purposely picked my input values to be the perfect squares. So I'm going to start by plotting these. So I have 0, 0. I have 1, 1. I have 4, 2. And I have 9, 3. Now the question is, how do I connect these? So if you remember, we can't have any negative. So that means this is my endpoint. I can't draw an arrow on the left side of this point because my graph starts here. I can't have any negative x values because if I plug in a negative input, I'm going to get an error for the real number system. So then I look at, well, can I connect these? Is it okay for me to take the square root of 2? Absolutely. It just means you're going to get a decimal. So to compensate for those decimals, we're going to actually connect these points because it's fine to have decimals, and by connecting these points, you're representing that decimals are okay in between here. And it's okay for me to plug in any number larger than 0. I could take the square root of 1,000, so that's why I put the arrow on there. So this would be the square root function. So this is f of x equals the square root of x. And here's my x and here's my y. And if you look, it looks very similar to the parabola. It's basically this part of the parabola reflected over the line y equals x, which tells me that it's the inverse. Now, we can't take the full inverse because if you remember, this does not pass the horizontal line test. It's not 1-to-1. If you reflect this entire parabola, you get a sideways parabola, which would not be a function. So basically, when we look at the square root function, we only plot the positive section of it. Otherwise, if you plotted the square root of negative, or the negative times the square root of x, you would have this bottom part, which would then not be a function anymore, because like if you did plus or minus the square root of x, it would not be a function. So that's why we only plot this part. So that means when we look at the domain is going to start at 0, because remember, there's a restriction. We can only have 0 and positive numbers. So 0 to infinity for the domain. And the range, well, you're never going to have anything lower than 0, because that's the minimum point you can plug in. So 0 up to positive infinity. Now, it's kind of hard to believe that this goes up to positive infinity, but it will. It just keeps growing really, really slow. And then the last two that we're going to look at is the cubic function and the cube root function. So cubic function is f of x equals x to the third. So for this, there's no restrictions because this is just like a polynomial. You can plug in any number and raise it to the third power. So let's go ahead and take some negatives and some positives so it's symmetric. So if I plug in -2, I'm going to get -8. Plug in -1, I get -1, 0, 1, and 8. Notice that when I plug in negative, it's going to stay negative because it's a negative times a negative times a negative. So we have -2, 8, -1, -1, 0, 0, 1, 1, 2, 8. And remember from the previous unit, we know that since this is an x to the third, one end should be going up, the other end should be going down. It's positive, so it's going to go in this pattern here. So now we're just basically plotting points more specifically to that. So it's going to look something like this. So then let's look at the domain and range of this. So the domain is going to be all real numbers. You can plug in any number you want. It's going to keep growing left to right. It's going to grow really slow, but it will keep getting wider and wider and have y values for all of these x values. And for y values, we're going to include all of these y values. It's going to keep on going, so -infinity to positive infinity. And then the last one here is the cube root function. So the cube root function is basically the inverse or undoing the cubic function. So the difference here, though, is when you do the cube root function, you actually do take this entire function and reflect it over y equals x, and it'll still stay a function. Where the square root, when you take the inverse of a squared function, you have to only take part of the answer, because otherwise the square root function will not be a function. So the cube root function means f of x equals the cube root of x. So when we look at this one, we have to think about, well, what works? So if I plug in negative numbers here, it's okay because you can take the cube root of a negative number. But just like the square root ones, you want to take square roots of perfect squares and you want to take cube roots of perfect cubes. So it would be convenient for me to start at, like, let's say -8, because -8 is a perfect cube. It comes out to be -2. It's convenient for me to take the cube root of -1 because I get -1. It's convenient to take the cube root of 0 because you'll get 0. 1, you'll get 1, and 8, you'll get 2. So you could say, oh, I want to take the cube root of -2. That's fine, but you're going to get decimals. So I purposely pick perfect cubes, so when I go to plot, it's just more convenient. So we're going to put our axes on there, and then let's go ahead and plot those. So we have -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And then when we go to connect these, it looks basically like the reflection of f of x equals x to the third. So this is f of x equals the cube root of x. So in the last thing, looking at the domain of this, it's going to keep on going in both directions for x. You can plug in any number you want for x. In the range, it will keep getting smaller and smaller, and it will keep getting bigger and bigger in terms of y. So the range is going to be negative infinity to positive infinity as well. So those are the basic parent functions, and then what we're going to start to do is we're going to look at a couple more types of functions, and then we're going to start looking at transformations of these functions. How do we move them around the graphs? What do the numbers mean that are added on at the end, or the numbers that are added inside of the function, the numbers that are being multiplied? We're going to look at how do those affect the graphs.